Last section we started talking about concentration. We said that we could measure the concentration of a solution in terms of molarity, which is moles of solute per liter of solution. So how many moles of stuff is dissolved into a liter of our solution. Now molarity is going to be a very, very useful concept for us in order to convert from moles to liters to grams of different reactants and products when we have solutions. So we're going to get really good at using molarity to do calculations. So here's an example of a molarity calculation and how we can use it as a conversion factor. So we're told that typical blood serum is about 0.14 molar NaCl. What volume of blood contains 1.0 milligram of NaCl? So I'm trying to find volume or liters of blood. Okay? Now I want to find out about 1.0 milligram of NaCl. Well, first off, I know none of my conversions ever deal with milligrams, so I want to get rid of my milli. So step one, let's change this to grams. Milligrams go on the bottom. Grams go on top. And I know, because I memorized my prefixes, that 1,000 milli is equal to 1 gram. Okay? So now I've got grams of NaCl. Well, I don't want grams, I want to get to liters. So I know I can get rid of grams. And I know I can change grams to moles. The way I change grams to moles is by finding grams on the periodic table. Na weighs 23. Cl weighs 35.5. So the whole thing weighs 58.5 for every 1 mole. Okay, so now is where it gets into new stuff. I want to get rid of moles, so I'm going to put moles on the bottom. Instead of moles, I want to find out about the volume. I want to find out about liters. This is where molarity comes into play. My capital M, molarity, is moles, so I have 0.14 moles of NaCl for every 1 liter of solution. So molarity allows me to change from moles to liters or liters to moles of something that I'm trying to find out about. Now I can just plug it into my calculator. So I'm going to take 1 divided by 1,000 divided by 58.5 divided by 0.14. And when I plug that into my calculator, I get 1.22100. Now, I know that I can only keep 2 sig figs. So I'm going to take off my 2 sig figs, or round it to 2 sig figs. So I get 1.2 liters of NaCl. And actually what I would probably write instead of just liters of NaCl is I would write liters of 0.14 molar NaCl, just to be a little bit more specific. But that allows me to change from one to the other. Okay? Ooh, no it doesn't. Hang on. Not liters. I left off my units. When you plug this into your calculator, be really careful you don't do what I just did. This is actually 1.22 times 10 to the negative 4th. Liters of NaCl. Okay, so be careful when you're looking at your calculator and don't miss those. Okay. Now, when we're working with solution stoichiometry, oftentimes you'll see this phrase called a standard solution. Now, what a standard solution is it's a solution whose concentration is accurately known. Now, what we usually do with a standard solution is we use our standard to determine the concentration of something we don't know. So it's a really helpful tool. So here's the way a standard solution works. In example 5, I'm told that to analyze the alcohol content of a certain wine, a chemist needs 1 liter of an aqueous 0.200 molar potassium dichromate solution. How much solid potassium dichromate must be weighed out, so solid weighed out, I'm looking for grams, to make this solution. So I'm trying to figure out how many grams of potassium dichromate I need to make a 2 molar solution, and I need 1 liter of it. Okay? So here's how I could solve this. I know that I need 1 liter of my solution. Okay? Well, I also know that it has to be 0.200 moles of K2Cr2O7 per 1 liter. See how I'm using my molarity? I know that molarity is moles of solute per liter of solution, and that allows me to cancel out my liters. So molarity I can use to convert from one unit to another. Okay? Well, now it's a simple, straightforward problem. Now I've got moles that I need to change to grams. So to make moles go away, I need to put moles on the bottom. I want grams. Now it's basic. I know that to change moles to grams, I need to find my grams on the periodic table. Potassium, K, weighs 39, and I have 2 of them. Chromium, Cr, weighs 52, and I also have 2 of those. Oxygen weighs 16, and I have 7 of those. So 78 plus 104 plus 112 gives me 294 grams. And I know that the number from the periodic table is always equal to 1 mole. Now I can just plug this into my calculator, and it's pretty simple. 1 times 0.2 times 294, and what I get is that I need 58.8 grams of K2Cr2O7. So to make my 0.2 molar solution, I would weigh out 58.8 grams of K2Cr2O7. I would put it in a container, and then I would add water until I have 1 liter of my total solution. So I'd add water, stir, 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 make sure that this is dissolving, add more water, keep stirring, add more water until I have exactly 1 liter. Okay? So dilutions are actually something that we get really good at as well. The reason is it's a lot cheaper for me to buy a concentrated solution and then use that concentrated solution to make the different weaker solutions that I need. The way that I dilute my solution is all I'm doing is I'm adding water. So I buy concentrated acid, And then when we only need 1 molar acid, I add water till it's 1 molar. Or if we need 0.1 molar, I add water until I get 0.1 molar. Well, how do I know how much water to add? Here's my equation for dilutions. Okay? M1V1 equals M2V2. Now here's what we would do for a dilution. What volume of 16 molar, this would be my M1, and I'm trying to find my V1 volume, must be used to prepare 1.5 liters. Liters is my new volume of a 0.10 molar, that's my M2 solution. Okay, so M1 V1, M1 is 16 molars. V1, I don't know. M2 is 0.10 molar. V2 is 1.5 liters. Okay? I want to solve for V1, so I'm going to divide both sides by 16. So V1 is 0.009375 liters. Now I can only keep 2 sig figs, 9.4 liters. Now here's the way this dilution would work. I would measure out 0.0094 liters. That's kind of obnoxious, so what I would actually do is I would measure out 9.4 milliliters of my 16 molar sulfuric acid. I would add it to a container that is 1.5 liters big. Now we've got these things called volumetric flasks that are used to make solutions, and they come in different sizes. So I would get one that was a 1.5 liter, and I would add water slowly so that I would actually get up to the 1.5 liter mark so that I have my solution. Now I said that backwards because that's not how I mix concentrated acid. For concentrated acid, add acid to water. And this will be an important safety tip that we'll talk about later. When we have concentrated acid, if we actually add it to water, it produces a lot of heat. If we add the water to the acid, the water can actually boil and it'll spit and it can cause acid burns. So we always add acid to our water. So I would actually probably add quite a bit of water first. I would slowly add my acid and then I would add more water to it. But I would need to add enough water to get up to this 1.5 liter mark. Okay?